2024 A-Level Combined Mathematics Paper 1 Part A question number 6. This is the integration question. The question says the region enclosed by the curves y equals 2 over x times the fourth root of 4 minus x squared, y equals 0, x equals 1 and x equals root 2 is rotated about the x-axis through 2 pi radians. So basically we have a region that is in between these four curves, is enclosed by them, and we take that region and we rotate it about 2 pi radians about the x-axis or a full circle about the x-axis. Now when we do this, we are asked to show that the volume of the solid thus generated is equal to pi times root 3 minus 1. Now for this question, we actually don't need a graph. We can go directly with the theory, substitute and get our final answer of pi times root 3 minus 1. However, I wanted to illustrate exactly what we're doing here, which is why I drew the graph. Now in this graph, this thing right here and this part right here are representative of the graph y equals 2 over x times the fourth root of 4 minus x squared. Now considering this, if we look at the other three curves, the curve x equals 1 is going to be this curve right here, which is a straight line that goes up like this at x equals 1, which for the relevant part of that line, I'm just going to draw this part. The entire curve of course is relevant, but in this case for our region, only this part from the x-axis up to here is relevant. Similarly, considering x equals root 2, x equals root 2 is going to be a vertical line like this that goes through x equals root 2, or the point at 1.141 and 1.414 and so on. Now considering that line is going to look something like this. Considering the other two, y equals 0 is just the x-axis, so therefore the x-axis is one of the boundaries of our region. And finally, this curve, which is this curve right here, is the last boundary of our region. Now considering those four curves and their boundaries, we can see the four curves bound this area right here. So this region right here is the region relevant to the question. It is a region that is enclosed by the curves y equals 2 over x times fourth root of 4 minus x squared, y equals 0, x equals 1 and x equals root 2. Now considering this region, what we're going to be doing is rotating the region about the x-axis by 2 pi radians. So basically, we're going to take this into the third dimension and we're going to rotate this region about the x-axis by 2 pi radians. Now when we do this, we're going to create a shape that looks something like this. We're going to have a small side, a big side on the back, and then we're going to have this curve going like this and this curve going like this. Now we can see if we take a cross section across in this direction like this, the cross section we get is exactly this region right here. So we have this radial symmetrical object that we have created by simply taking this region and rotating it about the x-axis by a total rotation of 2 pi radians. Now given this, how we find this thing's volume is by using mathematical integration. If you consider this object here, we can see, since it is radial symmetrical, we could draw a radial axis through it like so. Now when we draw this axis, we can see if we take a slice along the x direction of this object, we can see the vertical height or the radius of this object from the central axis at y equals 0 or the x-axis is going to be equal to the y coordinate corresponding to the y point on the curve of y equals 2 over x times the fourth root of 4 minus x squared. So here we can see the height here, or the radius here, is y. Now considering that, if we consider a small size slice of this object right here by going a distance of dx in the x direction like this, we can see we could slice this up into a tiny little cylinder, and that cylinder would have a radius of y and a height of dx. Now considering that, the volume of this little cylinder would be equal to pi r squared times h, where r is equal to y, so we're going to have pi y squared, and h is going to be dx, so it's going to be pi y squared dx. So therefore the volume of this small cylinder is going to be pi y squared dx. Now since we have to add all of these small cylinders for each of the given x coordinates from the starting point until the ending point, what we need to do in order to find the total volume here is to integrate this thing from the starting x value to the ending x value. So basically we integrate from, let's say, x1 up to x2, where x1 is the starting x value here and x2 is the final x value here. And if we take this integral, the value of this integral is going to be equal to the volume of this shape. Now for this particular situation, we can see the starting value is going to be x1, which is x equals 1, which is this point right here, and the ending value x2 is going to be x equals root 2, which is this point right here. And therefore we need to integrate from x equals 1 up to x equals root 2. Now furthermore, if you consider y is this thing right here, so we can consider y squared by taking this whole expression here, substituting it into here and squaring it. So therefore, if we consider the volume that we need, the volume we need is going to be what we get when we integrate from x equals 1 up to x equals root 2 pi times y squared, where y is this expression right here, dx. So considering that, the volume required, we can say volume required is equal to the integral from 1 to root 2, and here since pi is a constant, I could actually take pi out here and write pi times the integral from 1 to root 2 of y squared dx, and here y is equal to this expression right here. So if I substitute, I can do y squared dx equals pi times the integral from 1 to root 2 of, and if we take this thing and substitute into y squared, we're going to get 2 squared, which is 4, divided by x squared, which is going to be just x squared, and then 4th root of 4 minus x squared squared, which is going to be just the square root of 4 minus x squared integrated with respect to x, so dx. And this right here is the integral that we're going to have to solve. Now considering this integral, we can see we have an x squared and a 4 minus x squared in here, and we also have a 4 on top. Now for this thing, you should note, whenever we have something minus x squared square root or something minus x squared, and we also have x squared or something like that, we can usually substitute a sign substitution or cosine substitution in order to simplify the integral and make it something more easily solvable. So in this particular case, we can see on the inside of the square root, we have 4 minus x squared. Now because we have 4 minus x squared, this graph is only going to exist for x's that are not going to cause the 4 minus x squared to be negative. So therefore it's only going to exist for x's that are in between negative 2 and 2. Now due to this, if we use the substitution x equals 2 sine, let's say, theta, then we're going to be alright, since sine theta is going to vary in between negative 2 and 2, and x in this particular situation can only vary in between negative 2 and 2, and therefore this right here would be a valid substitution. Now let's try doing the substitution and see what we get. So let's say let x equal to 2 sine theta. Now from this, if we differentiate both sides to get dx, we're going to get dx equal to 2, and then derivative of sine x is cosine x, so we have cosine theta d theta. So therefore dx is 2 cos theta d theta. Now furthermore, considering the rest of the integral, we can see we have to integrate from 1 up to root 2. Now considering the substitution here, when x is equal to 1, we can see if x is equal to 1, that means we have 1 equal to 2 sine theta, meaning 1 over 2 is equal to sine theta, meaning that if theta varies in between negative pi by 2 and pi by 2, then we're going to have theta equal to pi by 6, since the sine of pi by 6 is equal to half. Now similarly, for the upper bound, we have x equals root 2, and considering that, we're going to have root 2 equals 2 sine theta, meaning that sine theta is equal to root 2 over 2 or 1 over root 2. And as we know, 1 over root 2 occurs when theta is equal to pi by 4. And therefore, we can say x equals root 2 implies that theta is going to be equal to pi by 4 for the range of theta from negative pi by 2 to pi by 2. So therefore, theta is equal to pi by 4. Now given this, if we substitute the integral, we can see the volume we get, volume is going to be equal to pi times the integral, and here we substitute the two limits. We're going to have pi by 6 up to pi by 4 of, and on the inside we're going to have 4 dx. Dx is equal to 2 cosine theta d theta, so we have times 2 cosine theta d theta divided by, and on the bottom we have x squared here, which is going to be equal to 4 sine squared theta, so 4 sine squared theta, and then we have square root of 4 minus x squared, and then it's going to be 4 minus 4 sine squared theta, which is going to be 4 cosine squared theta. Taking the square root of that is going to be 2 cosine theta, so therefore we have 2 cosine theta. And here we can see the 2 cosine theta here and the 2 cosine theta here cancel, and then we can also see the 4 here and the 4 here cancel, leaving us with just pi times the integral from pi by 6 to pi by 4 of, and here we have 1 divided by sine squared theta, which is going to be cosec squared theta d theta, and therefore the volume we're interested in is pi times the integral from pi by 6 to pi by 4 of cosec squared theta d theta. Now, as we know, the derivative of cot theta is negative cosec squared theta, and therefore the integral of cosec squared theta would be negative cot theta. And therefore, the integral here is going to be equal to pi times, and then the limits of negative cot theta from pi by 4, or rather pi by 6 to pi by 4. So if we substitute into here, we're going to get pi times, and then the upper bound is going to be equal to negative cotangent of pi by 4, and then minus the lower bound, which is going to be negative cotangent of pi by 6. Now substituting the values, we can see cotangent of pi by 4 is equal to 1 over tangent of pi by 4, which is just 1. So therefore this is equal to 1. And cotangent of pi by 6 is 1 over tangent of pi by 6. Tangent of pi by 6 is 1 over root 3. And therefore cotangent of pi by 6 is root 3. So therefore we have pi times negative 1 minus negative root 3. And therefore the negative and negative are going to cancel, leaving us with plus root 3 minus 1. And therefore our volume is pi times root 3 minus 1, and therefore we can see our final answer is pi times root 3 minus 1, and we have obtained it using the trigonometric substitution x equals 2 sine theta, and done all the substituting and gotten our final answer. So that's going to be all for this question. Now finally, let's discuss the marks award for this question. So at the start of the question, when you write that the volume required is equal to pi times the integral from 1 up to root 2 of y squared dx, and then you substitute y equals 2 over x times the 4th root of 4 minus x squared, for this substitution, you get 5 marks. After this, when you use the trigonometric substitution x equals 2 sine theta, and then you do dx equals 2 cosine theta d theta, and all of this stuff, and then you substitute and get this expression right here, for getting this direct expression with the direct substitution, you get 5 marks. Now after this, when you cancel out everything and simplify that thing down into pi times the integral from pi by 6 to pi by 4 of cosec squared theta d theta, you get 5 marks. After this, when you identify that the integral of cosec squared theta is going to be negative cot theta, and you write that the volume is equal to pi times the limits of negative cot theta from pi by 6 to pi by 4, you get another 5 marks. And finally, when you substitute, simplify and get the final answer of pi times root 3 minus 1, you get another 5 marks for that. So that is going to be all for this video and all for this question. So I hope you enjoyed. If you have any feedback, post them in the comments down below. Thank you for watching, and goodbye.